I went to go get y'all from the library to bring all of these.
Okay, the name of my project is the printing press, and it's okay. And you have to put the index card right here, and you have to pressing it. It's right there.
Well,
that's it.
It's not experience, it's a video we made, Jose and I made. It's about two important events that led to the French Revolution: the tennis court oath and the storming of the Bastille. And the first one is the tennis court oath, in which the peasants weren't allowed to vote with the nobles and the king, so they swore they'd meet up at the tennis court until they were given a fair constitution. And then later, they go to the Bastille. They go to the Bastille and they break down the door and they steal all the weapons that are inside. Yeah, we made the video, taking pictures and putting them together with iMovie. Yeah, and that's it. You're welcome.
Well, I tried to make a recreation of the cotton gin, which was created in 1793 by Eli Whitney. And at first he made the cotton gin, but his patent wouldn't go through, so he never made any money off of the actual cotton gin. But I made my own recreation, and you just put the cotton on the board and you brush out the seeds, and once the seeds fall through, or if they don't fall through, you just brush it in and you get clean cotton, and it's done. And you can make up to 50 pounds every day, and it helps speed up the process, and they were able to make better profit and more money. That's it.
Okay, the name of my project is The Collapse of the Roman Republic, and I made a video in stop motion from BC Rome, and it's supposed to be a commercial about why you should go to Rome. And that's it. Should I show it to you guys?
Okay, so this is a White Tower of London, and it was built in 1066 by William the Conqueror, and it was originally built to make a castle. Elizabeth I, Charles I, and James I all used it for royal authority to just to show off, I guess. And then they used it as a prison, and they would torture people in it. It's just weird, but yeah, that's basically it.
Okay, this is our interpretation of King Arthur and King Arthur's Camelot's Castle, where we combined engineering, arts, and literature together to create our interpretation, because apparently to scientists, the castle was never really found. Maybe it never existed, and neither did Camelot. So we combined technology by taking out a music box. We used a music box, and we used the machinery inside of it to make the door. So whenever you pull this knot, the door closes and opens like that. And whenever we try to use the outside of it, the part inside of it was actually our model from the Camelot Hotel, and the outside of it was ours. We created it by using different types of toilet paper and other things that we found in the house that was really not expensive. And the outside of it was also things we used from outside our garden, where the little rocks, we got them out from pebbles. These were spheres that were hanging out, and these were normal branches. And the moss, there were 2 different kinds. We actually had to buy those. And the color of it, we had to use 3 different colors to get actually this color. And also the cannon pole, we just used it out of cardboard, little sticks, rocks, and a spoon. And it actually does work. And also the parts from around it, like the little branches, they also are from the outside. So it was actually, it's natural. All the things that look like trees are actually natural. These are just cardboard, and it's really easy to use to make. Actually, it only took us almost 3 days. And the bottom part of the base is actually made out of rocks, the 3 layers of rocks. And we used a mirror and 2 birds to represent how King Arthur was never really found when he was taken to the castle. And some say that he turned into a raven, or that he was hiding under the castle somewhere, waiting until the world finally found him and needed him again. That's it.
Yeah. Okay. So this eventually, like this is mostly cloud in the bottom. So you just put alcohol into it, then you just mix it. Then you just put pressure into it. Go. Just put 5 times. Just let it go, and that's how it is. So that's eventually all we do.
So this is water, and it's polar, and like this is oil, and it's non-polar. And so like if we were to put like a certain amount of this inside of that, it'll float up to the top since it's oil and it won't mix. And then whenever you put this oil absorbing powder and leave it there, like since they both don't mix with the water, they like absorb each other, and then they make this thing. It's pretty cool.
Can they put on the glasses on the camera? No, what are y'all doing? You know what's going on. Okay. Wait. No, guys, come over here. Okay, ready? Okay. So our experiment is about instant snow. Right now, right here we have some type of chemical that makes snow, and we're gonna make some snow. We put some of this chemical in here, and we pour water. And in seconds, it makes snow. As you can see, it makes snow, and it looks just like snow. Right here, we have snow, but it's frozen. It is like real snow. Right here, we have the snow. We have the diaper, and it's the same material right here. It's just different chemicals, which causes the liquid to absorb it in baby's diaper. And right here we have cool glasses. It makes all the lights look like diamonds. That's it. I got that. Can we put it on the camera? Can we put it on the camera? Can you see? Look up.
Would you like to have your minds read by math?
Yeah.
All right. Pick one from these 2 columns, but
Okay.
don't tell me.
All right.
So, is that one you picked in the first column? Is it in the second column? Are you sure? Is it in the third column? In the fourth column? Yes. Is it in the fifth column? Is it in the sixth column? So it was in the first and the fourth column. Is it Georgia.
Okay, so we're gonna measure the temperature that this comes out as in the end. So we'll measure this, and it's 70 degrees Fahrenheit. So check. So the temperature went down all the way to 64 degrees Fahrenheit. And we're going to measure this. That went all the way to 39. So you can see the difference of temperature going from hot to cold.
Robotics team, FRC. And this year, this is our robot. We made it to throw frisbees, shoot them, and score points. And we've been in this competition for 4 years. And actually, this is my second year in it. And so far, it's going pretty good. I like it.
And well, basically, what this is gonna do, it's gonna throw frisbees, and there are 3 openings at the top, and the frisbees have to go in between the openings, and we score points through that. And the competition, is it also on balance?
Jamie.
Yeah, and we also have a camera that we could picture like where the robot is going and everything. And well, what this is, like he said, FRC is it? FRC. It's a bigger competition, and the other one's like a smaller competition basically. And this is for juniors and seniors, and that's basically it.
That's kind of how like lightning works, when it jumps from the clouds to the ground. And also we have a neon tube, and this is lighting up because the electrons are jumping from the Van de Graaff generator into the tube, which is filled with a neon gas, and as electrons pass through the gas, they excite the gas molecule, which causes it to emit a light. Yes. And this is the Van de Graaff generator for you. Thank you for your time.
Okay, you can talk about your experiment now. You don't have? Why? I'm already talking about it.
Well, basically what we realize is project-based learning, and it's very interesting, it's very cool to actually be able to do something different and very different. We actually were able to study about different people. We revived a debate between Dr. Booker T. Washington and Orby, and what we did is we tried to understand them, and then in class we did a talk show, which allowed us to not only know what they did and why they did it, but also to be in their place and to understand their activities better, and to get a better understanding about U.S. history, which is going to stay in our minds forever, because we have that experience that we actually did a talk show, and we taught the class, and we taught ourselves, and we weren't just there listening to the teacher. And we're about to show you guys the video.
So when it starts. Alright. These are the human body systems projects, and these are the mannequins.
We started with the brain up here, with each lobe, like the temporal lobe and the frontal lobe, and we worked our way down to the intestines and the gallbladder and the pancreas and stuff. And right now we are working on the muscles, like these muscles, and each of them have a certain special secret muscle. Like this one has the gluteus maximus, which is the butt, and they each have a little muscle where we are each working on it, and they each have their origins and their functions.
The model, and it's all labeled, and this is the kidneys, and it filters the liquid, and it'll go down the utera, and it'll go to the bladder, which holds it, and when afterwards it'll come down here through the urethra. And this is our video that we did that shows that.
This is the solar oven, our solar oven. This is known as the poor man's oven. You can't afford a real oven, you get some of this baby, the solar oven. Not only do you save money, you save resources, you save the world, you do all that nice stuff, and you cook some dough. Unfortunately, we cannot present our project properly because of the sun is not working that well, or it won't happen in the amount of time that we have at this establishment. So we cannot properly present our project. I apologize for that. And our board is pretty poopy because our science teacher, John Baptiste, gave us a last second notice, so we had to change it. So now it looks like that. But that's our project in a nutshell. Hope you enjoy.
Just record our faces so you know who did it.
It's separating hydrogen molecules from oxygen.
You can see one of them ash right here, if you zoom in a little closer. And these butterflies are the most common in the world, and the amazing thing is they don't have like mouths, they taste with their feet, because their feet like somehow interact with the flower to absorb the pollen, and also they have 10,000 eyes.
Angie cannot absorb pollen, she may die.
This is osmosis and diffusion of an egg. It's water going through a semi-permeable membrane. That's the vinegar. It's to dissolve the shell. That's syrup. It'll cause the egg to shrink. And that's water, which will cause it to expand. And it's the same thing in the gummy bears.
Hey, call Christian over here. Alright, well, cellular respiration, and it's about how sugar and yeast make carbon dioxide with water. And like you can see, the biggest one is hot water. The two medium-sized ones, one of them is cold and one of them is room temperature. And it produces carbon dioxide, and it's supposed to like make it bigger. That's it.
Go, you go.
I'm not.
You go.
Explain your project.
Okay, this is basically surface tension that keeps the water inside of the jar, like this. It's basically it. And right here, this bird uses evaporated cooling liquid. That is this green liquid right here. When the fuzzy head touches the water, the liquid go up and it will start dipping and dipping and dipping. Like every 1 minute, I guess.
It smells like alcohol.
There you go.
This project is reading minds by math. I can't reveal how it happens, but would you like to? Well, I've already had someone record this.
Okay, so we have a balloon, and what we did is that we put a little bit of water inside of it, and then so whenever the lighter gets close to it, it won't pop it because of the water. It absorbs the heat, and it diffuses it.
unless you put it up here, and then that way it'll pop. And then here we have silver nitrate and tin and chlorine. And so we connected a battery and we gave it current, and it goes from negative to positive. And whenever we did that, the current went through the silver nitrate, and it broke all the bonds. And then so that's why we see like crystals formed. And then whenever we did it with tin and chlorine, it became magnetic. And so that's what we see here is the times whenever we did it, and so they became magnetic. And that's it.
She's gonna talk first. Okay, so what this is a greenhouse, and what it's used for, it's to grow plants bigger, and when they grow, it grows bigger, stronger, and it has more fruit.
And also what it does is that it traps heat inside it from the radiation and wavelengths from the sun. And if it's too heated, you can either open the window or put wire in there where it could get the moisture of the soil and it could cool down.
Yeah, and when it gets too cold outside, you could also put a heater. Yeah.
And it's very convenient for you to place it where there's like a lot of sun hitting it, where they could grow plants better. It's not good.
During the summer, the sun hits directly down during noon, and then during the winter, it hits slanted. So you want it a place where it always hits the sun.
What we learned from this project is basically that how to take right measurements, how to build a greenhouse, and how to do other stuff, and how it actually works. So this is our board. We did research about it. This is what we thought. Some pictures. We're hardworking. And we used a lot of materials, also a lot of safety gear we had to learn to use, and able to use a saw and a screwdriver and a hammer.
Hello! Welcome to my little lab. As you can see, we ran out of chemicals as used to make this plentiful. Now, all we need for you to make it is you need soap. Yes! Once you wash your hands with, of course, you need like 4 or 5 squirts like this. And then after that, you use 4 little hydrogen peroxide to rub here to increase the amount of reaction. And then we need to use a multi-catalyst to speed up the reaction. But the bad news is, we ran out of sun, so I have nothing to do but create works of art. Yes, works of complete art. After slaughtering a bunch of balloons, which actually fell on me twice, as you can see from the bunch of balloon corpses right over here. All we need is just these little works of art like this. Oh yes, ladies and gentlemen, works of art is all beautiful. Oh my goodness, it's so beautiful and gorgeous in some sort. And the only way to make it, you just draw it out of marker first, and then voila! You just put alcohol on there, and it works! And then, batteries not included. Thank you for your participation.
Shakespeare, and these are his different types of sonnets and stuff. And on the very back, students wrote their own sonnets and stuff. And on this board, we're making everybody who came like sign their name on the hearts. And yeah, it's just Shakespeare and his sonnets, and yeah, that's it.
Not pop because the pressure of the needles are being distributed around the balloon evenly. This is oxidation. That's right. This is oxidation. You can't see it with the back flashlight. This flashlight. Oh, it's over here. It's oxidating because of the silver nitride reacting with the copper right here. And the flowers.
Oh yeah. This is an acid indicator. And this is ammonium and acid. And it turns pink.
Alright, so as y'all can see, our project is called One to Be Driven Insane. The reason we call it this is because this riddle drives you insane.
So as you can see, this video is composed of 12 people, all right? And the whole idea behind driving you insane is that we play the video, You count how many people there are, which are 12. We play it, and the computer does it for us. It mix matches. See, it mix matches us, and then we pause it. The riddle here is that when they mix match it, there's one extra person. The riddle is to see why and the explanation of.
They cut each person in half, and they switch their body parts, you know. But when they switch them, you start off with 12 people, and when you switch them around, you end up with 13 people, an extra person. And what we're trying to ask people is, how is it that we end up with that 13th person? Where does that 13th man come from?
Yeah. And so what we're doing is, you can observe over here, we're giving people note cards and a pen, and they write their explanation down, and if it's correct, then they get one of these 3 prizes. So yeah.
Thank you very much.
All right, thank
you. It's a robot. It's listening and puts it on the other peg. As you go to put it on the peg, you get more points. Well, I control the claw. See, I can drop it down. I can lift it up. My friend here controls the movements and the arm.
Okay, look, I will do something. No, I don't want to talk.
That's it.
Okay, let me calm down. Glove of 7 inches. This is an example of what we know lightning. This is the fourth state of matter. In the middle, it's what we call the testicle. The molecules that are inside, they are from the testicle, and they create an energy to go freely away from their home, which is the testicle. However, they do not run freely for a long time. They create more energy to go back to their home. The plasma is created of a mixture of gases, and that's what it creates all the lightning. The plasma glove is very small, but more importantly, it's a frequency alternative current. That's all. You need some more?
Let's take a call, then you give them BBS. As long as you like on you, throw your balloon on there. Ring, anything? Yeah, that's it. Take it off. Yeah. Put it right there. Put it on the side. Move it to the side. Move it over. Move it to the side. Yeah, push it. Okay. Push it to the side of the wall. It's right there with the headphones. Yeah.
University of Texas at Dallas, and this has been a terrific event. Had an opportunity to see a lot of different projects going on, learned some history. The water conservation project was excellent. We got to do a lot of different fun things just to have a good time and talk to a lot of great students. It's been a great event.
In my experiment, it's basically a demonstration of how you don't get all the germs on your hand. So this gel is germs, and you take it and you put it on your hands like lotion. I got too much, but you take it and you put it on your hands like it's lotion. And then you see you have the germs all over your hands. And so then you just wash your hands like you normally would to see how many of the germs you can get off, which most people think they get all the germs off their hands when they wash them. And then once you get them off, the lotion that we put on is actually glows, and so you shine a UV light on your hands, and then you can see all the germs that are left behind. which is actually a lot more than you would think get left behind. And they typically get left behind up in your fingernails. And so it shows that soap doesn't kill all the germs on your hands.
Hello everyone. My name is Amy Curtis. I am the Community Outreach Coordinator here at Harmony Science Academy, and we are in the midst of a really incredible, successful first of many STEM expositions today. And I'm really proud of the kids. They've done an amazing job. Everyone really knows what they're doing. They're enthusiastic. They impress. We had some VIP guests. We had professors from University of Texas at Dallas. We had representatives from the state of Texas. Their aides came, and everyone was really impressed with the kids. So it's been a great day, and really thankful to all the students and all the faculty members who worked so hard to make this day happen.
So what this is about the global water crisis, and it's just basically like how much little water that we have left. Like 97% of the Earth's water is too salty for anyone to drink, for us to use. 2% is locked up in ice, and only 1% is available for us to use. And then out of that 1%, 70% is used for agriculture, like farming and animals, and there's only 30% left for human use, like doing our laundry, taking a shower. So there's people all over the world who don't have access to clean water. Like most women and children, they have to walk 3 miles a day just to get water. And most of the time, when they do get water, it looks like this. It's often dirty.
And
it has
it also
salt.
takes 6 hours for them to purify the water.
Yeah, so we're just gonna show an example of how they purify the water. So this is just sand.
And sand absorbs
it acts as
all
a
the
filter.
little, it acts like a filter, and it absorbs all the little dirt and stuff that there
And this is called reverse osmosis.
Yeah.
This experiment we're about to do is called reverse osmosis.
And here we just have water, carbon, and dirt. So what it's doing right now,
you can see the sand. The sand is like a filter, and it collects all the dirt from the water.
And it's purifying the water, purifying the water. And this is what people do on a daily basis. It takes 6 hours for 1 gallon
of water.
Yeah, and so you want to show the difference?
Yeah. Then we have a flashlight.
Okay, well you can see the difference from this and this. This is what you get from this when you purify it.
What is the segment's final message you guys want to give?
We just want to tell everyone that they need to, over there you can see that it shows a bunch of ways.
And tell them?
No, it's alright. It shows a bunch of ways of how you can save water. So what you can do to help. Basically, we just want to, what we just want to send across is that we need to, notice that there's people all over the world that don't have water, and we take great advantage of it because we could just walk to the store and get water. So we just want people to learn how to conserve water so people all over the world can, have water too. Thank you.
Hello, and I am at the STEM Festival right now. It's very fun. I just got to demonstrate the Van de Graaff generator to people on the stage, and also on the stands outside, in the gym, and I love it. I hope we have this thing again. Thank you.
All right, we're coming from UT Arlington. We work for the ROTC program at UT Arlington. We're just out here today talking to students about potential scholarship options and what the Army has to offer at the college level.
You want to answer?
Just looking at all the things that these guys are doing at the fair, it looks like they've already got a great start on the whole science and technology field, and so we're here to show them how the Army can relate to that, how the Army can use people who are already ahead in the fields like that.
We did a causal dissection to show how the human eye works and what is inside of eyes. Here we have the cornea, that has the lens, the iris, the pupil. In the back of the eye, we have the retina, which is the blind spot 2. And at the back, very back of the eye, we have the optic nerve that connects to the brain and fix the image for us. So here we can show.
Right here you can clearly see that the letter is backwards, upside down actually.
Like in here, you can see the letter is backward, and so the optic nerve sends the image to the brain, and the brain fixes the image for us so we can see it normal.
What is your project about?
is frog dissection. And you just cut open the frog and see the organs inside of them.
Why are you cutting the frog up?
To see the organ inside and to tell if it's a female or a male.
Why are you
No.
I don't want to help her kill a frog.
Pacifist?
Huh?
Are you a pacifist?
I don't know what that means.
Okay. So our project is on gel electrophoresis. And let me just move this chair out of the way. Okay. So while she's explaining it to them, I'll just explain it to you, I guess. Okay. So basically, our project is to compare genes of a virus, which it's not a real story, it's not a real virus. They're just a fictitious story that we had to use for this project, and basically, it said that in Alabama, there was in a small remote town in Alabama, a virus came up, and about 30% of the people who caught it were killed. In Pennsylvania, a virus similar to that appeared, but it wasn't as deadly as the ones in Alabama. Then there was one in Missouri that came up, and our job is to try and figure out which one it's more similar to, the one in Pennsylvania or the one in Alabama. So the results are actually these two right there. They're better than the rest. This one's the best one. This one is the DNA of the virus from the one in Pennsylvania. And it's this first one right here.
DNA is negative.
Then the next one is the one in Missouri, then in Alabama. Basically, we looked at the DNA in it because it's separated into different strands, and we have to look at which ones they're most similar to. And we found out the one in Pennsylvania and the one in Missouri looked the most similar, which means that the virus that came up in Missouri wasn't as deadly as the one in Alabama.
We put it in dye.
So basically, gel electrophoresis, it's used to compare the genes. Like, you can use it for a lot of things. There's people who are in criminal investigation use it to to look at suspects' DNA and like compare it to the evidence found at the crime scene, and by doing so they can figure out who committed a crime. You can also use gel electrophoresis to compare genes in a parent and offspring, like in case you want to know if they're really your kid or not. And also you can use it in comparing the viruses, just like you did here.
The Alabama virus was a lot more deadly.
Do you have anything else to say?
Not really.
Thank you for your time.
Okay, thank you.
I feel amazing. I feel great. I just love the camera. I love it when it's on me. I'm in my groove. Any more questions?
Any more questions?
You epically failed.
How dare you giving me that with this?
I'll talk. What's the question?
I'll interview you. Basically, what I'm going to demonstrate to you is thermodynamics. So see, the flame doesn't pop the balloon because the water is absorbing the heat. So the heat's diffusing and it's not really melting the balloon itself. So basically, it doesn't get hot enough so the balloon pops. However, if you do somewhere where there is no water, this happens. Look at here. That happens. That's about all.
Okay, English or Spanish? So basically what this is, it's called a resonance bowl. What it is, it's a copper bowl with brass handles. What you do, you rub your hands on the brass handles, and the friction created by your hands and the handles make vibrations. The vibrations go throughout the whole bowl, but there are some areas in the bowl where the vibrations become very violent. In this case, once the vibrations become very violent, water begins to jump up and down. because it literally pushes the water against each other and crashes again back into the bowl, and it's basically what it does.
Oh, no other metal?
That's it.
Okay, fine.
Touch her.
Okay, just wait. Let it warm up. Okay, now I want you just put your hand like that. Just do that.
Just touch it. It's not gonna hurt.
Okay, now I'm gonna move this. I don't want you to move your hand now, okay?
Don't let go.
Ready? Don't move your hand. Keep it on there. You can see your hair right there. It's going up a little bit. Okay, try it out. Do you feel it? Okay, tell me when you want to get off.
Are you ready to get off? Let
Move
go,
your hand
step
back.
back.
Step
Let
back.
go and step back. That's all.
Okay, let go, step back. There we go. Oh, we got it. We got to tell them that she's still
What I
stepping
say?
charge.
This is me and Cepedita, Edgar's little brother. He's a little devil. And we have the experiment of the...
You have a couple of air cannons right here.
Yeah, the cannon.
Air cannons.
Air cannon.
And the thing about these air cannons is they hold stationary air. And when you pull back the plunger, you let that air go and let it go. You let that air go. And with this, you can do a lot of things that require air. You can shoot over cups, shoot people in the face.
Blow the candle.
You can blow out the candle if you can light it. Like so.
Yeah,
and right here we have a smoke ring cannon. That's what's up. Smoke ring cannon. Where I'm using a lot of this fake fog to make these smoke rings right here. Like that.
And for example, once you like are an expert at that, you can do it with your mouth. Show them. Where's the little thing?
What the?
Now you see. And that's all we're really doing over here. So, we should be good. And I'm just letting a lot of people have fun over here because, you know, this is pretty fun. So I'm just letting everybody have the kind of fun that they want to have with the air cannons and the smoke ring cannon. So,
what am I saying now? How the robot works? It is actually pretty simple. We're just using programming language, Verilog, and LabVIEW to program the robot, and we just tell it a couple of commands. And the basic thing is it'll throw some frisbees and shoot some obstacles. So that's it.